what I want to talk about now is a slight bit of a digression, because what I want to talk about is the interpretation of a coefficient using the Logit model. Now, the thesis that I have here is that you should not use the coefficient, and you also shouldn't use the odds ratio to be a measure of the impact of x on y. You should stick to looking at marginal effects, which were discussed in our last lecture. So you can either trust that, or you can look at what the meaning of our coefficients really is in this lecture, which is simply emphasizing the point that they don't have much meaning aside from a sign, and we also can look at the significance levels. So our Logit function takes our z and takes the exponent 2z in the numerator and 1 plus the exponent in the denominator. We'll keep that in the back of our mind, because what we're going to show and figure out is we want to be able to talk about what the betas mean. So I'm going to start off by writing our familiar form for the probability that y is 1. Getting ahead of myself with that given. That y is 1 given all of our x's. And we were using the shorthand of z to be the beta plus times the x's all summed up. And we said that with the Logit function, this probability was e to the z over 1 plus e to the z. So what I want to show you is the relationship here between our Logit function and odds ratios. But I first want to explain odds ratios and odds in this context. So an odds is the probability that something happens over the probability that it does not. This is the probability that happens. The probability that it does not is the probability that y equals 0, which is 1 minus the probability that y is 1, which is 1 minus e to the z over 1 plus e to the z. With algebra, we can just write this as 1 over e to the z plus 1 minus e to the z and finally simply 1 over 1 plus e to the z. So this is the probability that it happens, this is the probability that it does not. So your odds are the ratio of it happening to it not happening. So if they're equal odds, it's 1 to 1. So it's e to the z over 1 plus e to the z. That's our probability that it happens over the probability that it does not. This is the odds for a given value of z. So this is a function of our x's. Now what I want to talk about is how do the odds change when we change x. Well, if we change x by 1 unit, we change z by beta 1. So the probability would be now z plus beta 1, And if we all go all the way down to getting new odds, all right, odds with increasing x by 1. We could do that whole exercise, we'd end up with the same solution with one thing different. Adding beta 1. We've done the odds for each, which is the probability of success over the probability of failure. Now we're going to do the odds ratio. So a ratio is something divided by another, and it's what we're going to use are these two different odds. So it's the ratio of the odds. Now, generally, aside from this application, no one ever talks about ratios of odds. It's basically ratios of probabilities, and in terms of conceptualizing, it just does not work well. So we have the odds of where we're adding 1 to x1 over the odds where we are not, where it's just the original. And we have our odds, which is e to the z plus beta over e to the z. The z's cancel out. And we're left with e to the beta. Okay. So the odds ratio is e to the beta, which means that the natural log of the odds ratio is beta 1. It's mathematically nice. It no longer depends on z. So this is not a function of anything. However, in doing so, we've removed almost all interpretation. The one thing is that we can say is we can say that if beta 1 is positive, z is increasing. Also, if beta 1 is positive, the odds ratio is greater than 1. You could also think about that in terms of what is happening to our probabilities. If beta 1 is positive, increasing x is going to increase your odds, which is going to increase your odds ratio greater than 1. A negative beta, which means increasing x decreases your probability, means that we would have a odds ratio that is less than 1. Odds ratios are never negative. This is e raised to the power. When you're doing your stata output, what it gives you by default is the raw betas, the coefficients from your regression. The interpretation that is correct is these are log of odds ratios. That's technically correct. You can also ask for the odds ratios, or you could calculate them by hand by simply taking an exponent to your betas. Both of those are very difficult to mentally interpret. I would really advocate that you look at marginal effects to know the impact of x on beta. Thanks for watching this very, very short mini lecture on the meaning of the Logit coefficient. The probit coefficients have even less meaning. You can just think of them as artifacts again, and to interpret those you can look at the marginal effects in the same way that we do for Logit. However, with Logit there is the temptation to use these interpretations. You might even see these in papers. They are hard to work with, hard to conceptualize, and easy to mess up, because an odds ratio is not the same thing as odds, is not the same thing as probabilities or changes in probabilities. It's hard to keep all of that straight. Hope you're doing well. Take care, and I'll speak to you soon.